Hello, Stevenson. Only you are there.
Sir, good evening.
Okay, you're inside. Just joined. So, if you hear some background noise, I'm really sorry. It is my mom teaching an online class. She's also a teacher. She works in a government school. She's teaching her kids online. So, you might. Yeah, I have tried my level best to cover up the noise, but still, if you still hear it, can't help it. So, guys, school started. How was it? First day school after a long time.
Sir, it was yesterday, sir. We had
How it was
practice.
yesterday. That's what. Anyways, you would have met your friends after a long time, put on uniforms, ironed it after a long time.
Yes, sir. Sir, social distancing, scene down போட்டாங்க sir.
அப்படியா கண்டிப்பா அது இல்லாம எப்படி டெஃபினெட்லி அட்லீஸ்ட் அந்த ஒரு கொஞ்ச நாளைக்கு இந்த ஷோ இருக்கும் லைக் அட்லீஸ்ட் 1 or 2 months it will be there இல்லடா
No,
அதான் பிரச்சனை.
sir, there was no social distancing.
Oh, there was no social distancing and then
At least,
absolutely fine.
at least for like the first few minutes, like just before they called us to the class, we were in the waiting
Uh-huh.
room. அப்பெல்லாம் ஒண்ணும் பெருசா
Uh-huh.
no. But
Uh-huh.
when we had to go and put papers there, அப்போ they were so, you know, keen on social distancing. I don't get the idea behind that.
Yeah, it's good that I little belong to your generation, so I understand. Yeah, previous generation people, yes, it's pretty tough to understand them. It's really sometimes they might act weird. Can't help it. That's how they are. So yeah, but no, it's not only there, Kana. It's actually I went to Kerala for New Year. You must really come and see. At least in Tamil Nadu, little bit at least it's okay. That I think in other states, I think they don't know what is social distancing. But anyways, now the cases are also coming down. Vaccine started, so yeah, lesser things to worry.
Yes, sir. Tamil Nadu is doing well, sir.
Yeah. Tamil Nadu, like this thing. What is that? It is actually becoming like a role model, not only for India, like it's to the whole world. It's actually they're doing good.
Yes, sir. Compared to the population that we have.
Correct. Like that way, Uttar Pradesh is also like doing a decent job. Uttar Pradesh has the what is that population of around 2-3 European countries put together. So yeah, they also did a decent job. They even got a mention from WHO, Uttar Pradesh, and even Kerala got a mention. What is her name? The health minister. So very famous lady. So she also got a good appreciation. So, anyways, I think we have 1, 2, 3, 4 of you. I think we can start. If your friends will join, let them join. Share my screen. Okay, so what did I say? Oh, why is it? Oh, no, this thing is not in tablet. So we were doing ionic equilibrium, right? So we have completed all the theory parts, right? So the last thing which we saw was not this, maybe yes, this one, right? So the last thing we saw was about what is that? Buffer solutions and solubility products, right? So let me see where it started. Oh, I think we finished this thing. Okay, it's here. All right. So yes, buffer solutions. There are two types of buffer. We saw how to make these two buffers and why they are used, right? So to just control the pH of the reactions, right? Just give me one. Just give me. Okay, right? So we saw how to, why they are used, how they are able to control the pH, right? So in case if it's an acid, it's causing a problem, I go for acidic buffer. If it's a base causing the problem, then I go for basic buffer. You know how to prepare them. An acidic buffer is prepared by mixing weak salt and the salt of the weak acid and the salt of the weak acid. And a basic buffer is prepared by a weak base and mixing it with the salt of a weak base. So these are the examples. And then I told you what is the formula. This is basic buffer. Okay, so this is the in case of basic buffer, we calculate POH, and that's the formula. And then this is the, where is it, pH. Okay, and then this in the case of pH of acidic salts, it will be pKa in this case, and instead of base you will have acid. That's it. That's the only difference. And then we went on to do some problems. Yes, products, and then we went for solubility product. Yes, absolutely. Right. So solubility product, I told you that we are going to see it only for sparingly soluble salts. Again, for the reason that um, reversibility, right? I don't want something to become zero. Anyways, now we started with what is solubility, right? So solubility means it is the amount of solute required to make a saturated solution, right? It's all about being saturated. No more solute can be added after that, right? Okay, so it is now with the letter S, right? So I told you there are two things regarding this, just to check whether you have reached saturation or not, or how much is required to do to get the saturation. All these things can be mathematically calculated with the help of these two, KSP and KIP, solubility product and ionic product, right? So in solubility product, I take the solubilities of each of the cation and anion and then do the solubility product, and you have to make sure that you're going to do everything which is required for an equilibrium constant, in the sense that if you have Mg2 plus and Cl2Cl minus, you're going to put S and 2S, and you're going to put a square also, right? And you can see here it will become AlCl3, it will become 27 S power 4. How you hope you remember how it came. Right. So going to ionic product. Now there it did not necessarily be always a saturated solution. It might can be in between, say whatever the initial concentrations you use, all these things. Right. So you can see here, if I have 10 power minus 3 NaCl, it's just going to be 10 power minus 6. That is the ionic product. And again, whatever you follow for equilibrium constants that you follow. So ionic product in this case will be Al3, a concentration of Al3 plus into concentration of Cl minus. But since there is a stoichiometric coefficient of 3, you put a 3, right? So done. And then we saw what is the conditions for forming a saturated, unsaturated, and precipitation, right? So if you find the ionic product is lesser than KSP, that is means unsaturated. If it's equal, it's saturated. And if you find that it is going to be more than that, then definitely precipitation will happen, right? So this is what we saw. So let us do some good number of problems, and then we'll wind up this chapter, right? And hope you got the schedule. I think this is the first day you are having the extra classes. So chemistry will be happening on Monday, Wednesday. Oh, yeah, Monday, not Wednesday. Monday, Thursday, Friday, Saturday, Sunday, right? So yes, so we will go for the problems. Okay, just give me a moment, guys. I'll just do the problems. Okay, fine. So we'll do the normal procedure. I'll send you the questions on WhatsApp. So please check your groups. Let's check it. Sorry, guys. Yeah. So the question number marked 13. I should have got it. So the question says, a weak monobasic acid is 1% ionized at 1 m. What is the percentage ionization of that particular acid when the concentration is 4 m? Okay, question seems very simple. I mean, just a small question. Yes, you try. I'll give you, what is the time? Time is 5:14 till 5:16. At least get me the approach of how you do the problem. Please use your pen and paper. Do not sit and do not just think in your mind. It's not going to help. Did I unmute myself? Oh, yeah. Okay. Just check who are not there. So Sanjana is not there. Sri Harini, Sai Harini or Sri Harini is not there. Okay, fine. So I'll answer this question. If they say that the acid is 1% ionized, what can you, which value will you be able to find out with that? If they say if it's some percentage ionization is given, what value will you be able to find with that? What are they talking about there? Which term? Which term is it?
Sir, we can find K, sir.
We can find what?
Sir, the 1% ionized means you can find alpha, sir.
Absolutely fine. So can you tell me what is the value of alpha if it's 1% ionized?
It's 1/100.
Good. Right. So yeah. So it means the alpha value is 0.01. Okay. So that value is given to you, and the initial concentration is also given to you. Now, guys, tell me. This actually is a very easy question. If you just remember one of the properties of equilibrium constant, and that is what is going to help us here. What do you think is what? Like, tell me what are the properties of equilibrium constant? There are some properties, right? Can you just list out whatever you remember? It might not be relevant to this, but whatever you remember, just tell me what are the properties you know regarding equilibrium constants. Yes, there are so many. What is that?
So it changes with temperature.
Okay, fine. That is one property. It changes with temperature. Okay. What it doesn't depend on? It's dependent on temperature. Equilibrium constants are independent of what?
Concentrations of
What concentration?
reactant.
I mean, concentration. Okay. I mean, say. I just want the correct word. It is independent of dash concentration.
Initial concentration.
Absolutely right. So it doesn't really depend on what is your initial concentration. Whatever you start with, say you start with 1 m or 4 m, the equilibrium constant is going to be same, right? That is the property of equilibrium constant. That is what is you're going to use here. So irrespective of whether I'm going to have 1 m concentration or whether I'm going to have 4 m concentration, the alpha value might change definitely, but the Ka value is not going to change. That's the hint, right? So then I think the problem is very easy, right? So just you have to do, now you can tell me how you're going to do the problem.
How will you do the problem? Now that you know this hint. So if initial concentration, yeah,
equal to 3 alpha square.
okay.
Is the answer 5%?
I'm not sure. Let me check. We'll check that. But anyways, fine. So just you have to use this formula 2 times. Ka is C alpha squared. Say first time the concentration is 1m and they have given the alpha value to be, so concentration is 1m. Why is this happening? Okay, fine. So concentration is 1m and the alpha value they have given to be 0.01. Right? So that's it. Now you know the Ka value. Now this Ka value is not going to change. Same Ka, but this time the concentration is 4m, not 3m. Right? And now find your alpha square. Right? That is what they're asking. That's it. Right? So I think it's a simple calculation. So you would have got the answer right, I suppose. Right? So it should be yes, 0, I think 5%. Yeah, it should be. Right? Yes, correct. Okay, so it's a very simple problem, right? The only thing which you have to remember is equilibrium constants does not change with the initial concentrations. Okay, fine. Moving on. I hope everybody understood the problem. Right, next question. And I'll ask you one more question. So I told you there is a trick to find out whether the question is coming from buffer solutions or from salt hydrolysis. How will you find that out? I told you, right? How to do it? Because there will be pKa's, pKb's, concentrations, everything will be there for both of them. So how will you find out which question is from what? Yes? Anybody remember? So if you just write the formulas, fine, tell me. We'll just list the formulas out first. Okay, so going for salts, right? Okay, now tell me if I have an acidic salt, what is the formula? pH. What is the formula? Yes, formula? Acidic
Minus log
salts.
of
Minus, no. That is the normal pH we find. That is the general formula. Now for an acidic salt and a basic salt, I gave you a pH and pOH value. What is that?
pKa plus
Salt. So first one is 7. Now this is an acidic salt, so pH should be lesser than 7. 7 minus half into pKb plus log C. Right? This is the formula. If it's a basic salt, yes, formula pOH. Oh, no, this is pH only, not pOH. That's only for buffer solutions. So pH will be 7 plus half into pKa plus log C. Right? This would have been the formula for acidic and basic salts pH. Right? Now, when I go for buffer solutions, right? Say when I go for first acidic buffer, right? So there I calculate pH, right? That would be pKa. pKa. plus log of salt concentration divided by the acid concentration. Right, now if it's basic buffer, then I go for POH, which would be pKb plus log of salt concentration, right, divided by the base concentration. Okay, so guys, if you don't remember the formula, simple questions also you'll not be able to answer. Anyways, now if you look at the formulas, right, now see, in case of salt hydrolysis problems, you require just the concentration. This C represents the concentration of the salt. I don't know why. I really have to change my stylus, and I've been telling it for a longer while, but I'm not doing. Okay, so this is the concentration of salt. Same here, concentration of salt. And here, you see, you require both the salt concentration as well as the acid concentration or the base concentration. So if two concentrations are given to you, that question is from buffer solutions. And if only one concentration is given, that is about the salt alone, not on anything, nothing regard to acid or the base, then it is going to be on salt hydrolysis. This is how you identify the questions, people. Please do not forget, right? It's just simple 4 formulas, and it can be a little confusing when it comes to problem solving. It's just identifying which question is that. Okay, fine, cool. So now we will go. Let me send you a question. Okay, so there are 2 questions in this. I have marked it 5 and 6. Okay, first we'll do the 5th problem. Okay, so amount of ammonium sulfate which must be added to a 500 ml of 0.2 m NH4OH solution to yield a pH of 9.26 is how many moles? Right, to tell me whether this question is from salt hydrolysis or from buffer solution. They're asking you what is the amount of ammonium sulfate which must be added to NH4OH to yield this much pH. So this is what? Salt hydrolysis or buffer? Quick.
I think
How
the
many
buffer.
concentrations are given? I mean, see, correct, right? So in the 2 concentrations are not given, but you are going to work with 2 concentrations, right? One of the concentration is asked, right? So they're asking you what is the salt concentration, and they have given you what is the concentration of the base, right? And they've given you the pH value also, right? So this question is definitely from buffer solution problem. And it's what kind of buffer? What kind of buffer? Acidic buffer, basic buffer? Which buffer? Which buffer? What is it? What is NH4OH?
Base.
Basic,
right.
sir.
Thank you. It's basic buffer, right? So now for basic buffer, we have only POH, right? So now you have to find pH. I mean, they have given you pH. So if you want to use this formula, you have to find POH first. And then you can see everything is given. pKb is given. Salt concentration is what we have to find out. That is the salt concentration of ammonium sulfate, and the base concentration is given to us, right? Base concentration is 0.2 m. right? Okay, it's a very simple problem, right? So if the pH is 9.26, what will be POH? It will be 14 minus pH. So 9 means 5 minus 0.26 will become 4.74. So POH is 4.74. That is found out from pH plus POH is equal to 14. Now pKb is equal. So pKb is given as how much? 4.74, right?
Sir,
Plus
what's the
log
equation?
of the salt. Sorry,
What's the equation again, sir?
what is it? This one, basic buffer formula. POH is equal to pKb plus log of salt concentration by base concentration. But they were not giving me POH, they're giving me pH. So I can find 14 minus pH. That will be POH. That's how I got 4.74. Right? Okay. So log of the salt concentration, I don't know. See, and they're asking you the question in terms of number of moles. Please look at that. Look at the options. Right? So I know what is the formula for molarity. It is number of moles by volume. And what is the volume? Tell me. What is the volume? Look at the question and tell me what is the volume. What is the volume given in the question? Guys, are you sleeping? Or are you tired because you came back from school?
No, sir.
0.5 liter.
Is it not mentioned? What? I didn't get you. Someone said something. Can't you not see? It's given the amount of NH4 in ammonium sulfate, which must be added to 500 ml of this solution. So that is the volume. 500 ml is the volume. Because this ammonium sulfate will be maybe in the form of a salt, like solid form. It is not going to have its volume of the own. But I already have NH4OH solution with me, whose volume is 500 ml, right? So this V here is 500, right? Obviously, I have to put 1,000 because it's in ml, right? Or you can just put 0.5, anything is fine. Okay, so then the concentration of the base, that's the formula. Concentration of base is 0.2. Directly I can write. Right, done. That's it. Now 4.74, 4.73 will become 0 is equal to log of n by 0.5, or I can say fine, n by 0.5, right? Okay, actually, if I can do the calculations properly, so this will become 2n. 2n divided by 0.2 will become 10n, right? Now this is okay. Now this is log to the base 10, right? So you have log of what is 0? Tell me.
One.
Log of 1 is 0. So can I say 10n is 1? So n is 1 by 10, which is 0.1 moles. That's it. I got the answer. So answer is A. Yes, simple problem, right? It's just formula substitution, but you just have to know where to use what. Right? It's pretty simple. Now I think I like either you got confused with the volume or nobody wants to tell the answer. But if you got confused with the volume, this is how you're going to do it. Take the volume of whatever they gave you in the question. That's it. Right? Okay, next question. Sixth question. Yes, the question says 20 grams of NaOH is added to 0.5 liters of 1.5 m NH4Cl solution. And they're given the pKb of ammonia, and they're asking what is the pH of this resultant mixture. Again, the first question, where is the question from? Buffer solution or from salt hydrolysis? Just think and tell me. Yes, tell me. Is it from buffer solution or from salt hydrolysis?
Sir, is it salt hydrolysis?
Okay, this is a little confusing, isn't it? So now see, the two things you're adding is NH4Cl, ammonium chloride, and a base, and a strong base, NaOH. So this is pretty confusing, correct? But what you have to understand is there is going to be a reaction which is going to happen. That is NaOH. If it reacts with NH4Cl, right? So I am going to have NH4OH plus NaCl. This is going to happen. And this reaction is not going to go to completion. That means this is not 100% completed. So what you have in the mixture, you will have some amount of NH4Cl and you will have some amount of NH4OH. Okay, so this question is actually from buffer solutions, because you're adding a salt and you have a base, right? So again, it's going to be from basic buffer, right? Now, how do you do the problem? I just again give you 1 or 2 minutes. Just think about it. I'll help you out anyways. That means we'll look for a question. So, okay, fine. I'll give you some more time. I should not be interrupting your thoughts. Yes. Did you come up with an approach of how to do the problem? Okay. Fine. Let me write the reaction properly. So that. Okay. So this is going to give me NH4OH plus NaCl. Right. Okay. So now they have given me 20 grams of NaOH. Right. So I'll just calculate the number of moles of NaOH here. So that I know the molecular mass is 40. Right. This would give me 0.5 moles of NaOH. Right. Now NH4Cl, they have given me the molarity and the volume. Right. So I can find the number of moles. Number of moles is molarity into volume, and that would become 1.5 into how much? 0.5 right? So 1.5 into 0.5 is how much? It will be 1/2. I think it's 0.75. Yes. Is it correct or not? Yeah. Half of it, right? Half of 1.5 would be 0.75. So yeah, it's 0.5, 0.75 moles. Okay. Now you see, according to stoichiometry, right? Am I doing correctly? Yeah, okay. So according to stoichiometry, you see 1 mole of this requires 1 mole of this, right? But I have 0.5 moles of this, so I require only 0.5 moles. But you see, there are 0.75 moles of NH4Cl. Okay, right. So I know this is the limiting reagent. Hope you remember what is limiting reagent, excess reagent, whichever is going to decide the amount of products, whichever is exactly there to be the required amount. That is my limiting reagent. Right. Okay. So I have 0.5 moles that is lesser than this, right? So definitely this would be my limiting reagent exactly to the required amount, and this is in excess. Okay. So now 1 mole of this gives me 1 mole of this. So if I have 0.5 moles, this also would have been 0.5 moles, right? Okay. Now how much amount of this would have been left? How much amount of NH4Cl would have been left after the reaction has been completed? Hope you understand my question. I'm asking how many moles of NH4Cl?
0.25.
Absolutely right, because 0.5 of this requires 0.5 of this, right? So out of these 0.75, 0.5 would have reacted to form this. So obviously I'll be left with 0.25 moles of NH4Cl. Done, right? Now that's it. Everything else is not going to be helpful for me. This is not going to be helpful. This is not going to be helpful. So now you see, you have some mixture of NH4Cl and some amount of NH4OH, and that is going to make the basic buffer, right? Okay. So now it's all about formula substitutions, right? So now again, if you use the formula, now fine. So I have the concentration of NH4. Actually, these are the number of moles. I have to find the concentrations. So first, let me do that. So first, concentration of NH4OH. If I calculate, it would be 0.5 is the number of moles. Now, what is the volume? Volume. What is the volume? Number of moles per volume. What is the volume? Again, please look at the question and tell me what is the volume.
0.5 liters.
Yes, that's it, 0.5 liters. That's the only volume which is given to you. There's no other volume, right? So it will be again 0.5. Okay, right, that's basically going to be 1m for NH4OH. Next, NH4Cl would be, this is the number of moles, 0.25 after the reaction has completed. Again, the volume is going to be same because they're going to be in the same mixture. Now, in this case, it is going to be 0.5 m. Can I say 0.5 by 0.5, 1/2? So it is 0.5 m. And that's it. It's just going to be formula substitution. The OH would be pKb. pKb if ammonia is given. I told you ammonia or NH4OH is going to be same. When you put ammonia and you dissolve ammonia in water, you're going to get NH4OH, right? Fine. So 4.74 plus log of the salt. Salt is NH4Cl. This is 0.5 divided by base concentration. Base concentration is 1m. Done. So 4.74 plus log of 0.5. This is not going to be there. So 0.5 I can write it as 1/2. Right. So again, this whole thing I can write it as log 1 minus log 2. Log 1 is 0. So what I'm left with is 4.74 minus log of 2. Log of 2 value you should know, as I told you, is 0.3010. So 4.74 minus 0.3 will become 4.3 approximately. Sorry, 4.4 approximately. Right. That is what is the P. Oh, wait. We are doing it wrong. What are we doing it? What are we doing wrong? This is not the answer. Why is this not the answer?
Sir, we are finding the pOH.
Absolutely. Right. This is the pOH value. See, the option is there, and I was about to tick it, and I would have gotten -1. Right. Fine. This is pOH. So pH would be 14 minus this, which would be 11.6. That's the answer. Right. 11.6. Is it there? Oh, why am I not finding the answer? What did we do wrong? Oh, it's sorry, it's 9.6. I'm really sorry. Calculation mistake. Right, 11 minus 14 minus 4.4 will become 9.6. Yes, option is there, and that would be 9.56 approximately. That would be it. That's the answer. Yes, guys, everybody got the question. Please give me a yes. This includes stoichiometry, right? This includes stoichiometry as well as the buffer solutions. All right, they have given you a base and a salt. So you just have to make the reaction, do the stoichiometry, find the excess and limiting reagents, and find how much is left, right? And then use the formula of pOH to find the pOH and then find the pH. Yes, everybody got it?
Yes, sir.
Okay, fine. I hope everybody got it. If not, please ask me. I'm ready to explain again. Okay, fine. Okay, next question coming on your way. Yes, it's there. Question number 5. Okay, I think it's a straightforward question. First of all, which area the question is from? 5th question. pH of 0.01 m calcium acetate is this much. Okay, that's what they're asking. Find the pH of 0.01 m calcium acetate. 1 second, guys. Okay, fine. Yeah. So, which area the question is from? Yes. Which area question is from?
Sir,
How
not
many
sir.
concentrations are given?
One concentration.
Sorry.
Only one concentration is.
That's what. So what? Which question is then? Is it then?
Oh, salt hydrolysis. Which?
Absolutely. Right. So they have given correct. It's salt hydrolysis only. Correct. Right. So yes. So this is from salt hydrolysis. Right. Calcium acetate, just the salt, and now information about the acid or base is given. I mean the concentration values I'm talking. Right. Okay. Now tell me, calcium acetate is an acidic salt or basic salt?
Acidic.
The basic salt.
Come back to that. So, okay, settle the dispute, right? So you see, for forming calcium acetate, what is the base? What is the acid we Ca. This is what they, oh my god, what happened just now? It's better, but okay, better. Fine. So I'm asking, I have CH3COO twice Ca. Now tell me, what is the salt? I mean, what is the acid and what is the base?
So the acid is acetic acid and the base is calcium hydroxide.
That's it. Okay, good. So I need to
Yes, sir.
put
Then it will be basic only. Sir.
absolutely right. Okay. So you would have had CH3COOH plus CaOH twice, right? So I know this is a strong base and this is a weak acid. So definitely this is going to be a basic salt, BS, basic salt, right? That's it. You just have to use the formula, right? So what is the formula? Something is wrong with my touch. I have to remove the charger. Okay, it's better. Fine. So the formula pH would be 7. This is the basic salt, so it's 7 plus half into pKa plus log C. That's it. Just substitute, right? So it will be 7 plus half into pKa of acetic acid is given to us, that is 4.74, plus concentration of the salt, which is 0.01. That's it. 7 plus half into 4.74 plus 0.01 will become just 4.75. Right, so half of 4.75 would be 2.325. Okay. So 7 plus 2. It become 9.
Log C means it has to be -2, no, sir, because log of
Sorry.
0.01. Sir, you're taking
I don't
log C
understand.
now. Sir, log
Tell
C
me.
means it's, sir, are you able to hear me?
Yeah, I'm able to hear. Tell me.
Sir, if you're taking log of concentration, then it's log of 0.01.
Oh. Thank you so much. Right. Absolute mistake. Very big mistake. Right. So it's going to be log of 0.01. Absolutely. So it will be log of 10 to the power -2. Right. So log of 10 to the power -2 will become -2. I hope you remember how it came. Log of 10 is 1, -2 will come this side. So it will become, so 4.74 -2 will become 7 plus half into 2.74. So 7 plus half into 2.74. Again, I think it will be 1.325. Right? So 1.325 plus 7 will be 8 point something. Yeah, 8.52 approximately. So yeah, that's the answer. Okay, done. So that's salt hydrolysis problem, and that was an basic salt. Okay, fine. Okay, we'll go to the next problem. So this is a previous year problem. Okay, so you see, fifth question. A solution which is 10 to the power minus 3 m in each of these all cations is treated with 10 to the power minus 16 m sulfide ion. Now they're asking which one will precipitate first. Okay, so this question is straightforward. This question is from solubility product and ionic product. Okay. So you tell me the answer. I will give you, it is 1754, 556. You're going to tell me the answer. At least the approach.
Sir?
Oh, yeah. So there was a little network issue, guys. I'm sorry. I think I'm back. Right. Are you able to hear? Yes? No?
Yes, sir.
Yes,
Okay.
sir.
Okay. So yeah. No, why is it coming like this? 1 second, guys.
Sir, Varun should make you host, sir.
Sorry.
Varun should make you host, sir.
Oh, that's why. But I
I'm
want to
watching.
share my screen. Oh, you're not able to see the screen, isn't it? Oh, I'm sorry. Okay, I understood what's wrong.
So it's because he left, so we can.
Yes, sir. I changed it also.
Okay, I'm the host. Got it. Okay, let me share my screen. Where is it? I think now you're able to see my screen. Okay, one more. Okay. So yeah. So what I was asking, I think I was speaking to myself for a long time. Fine. So anyways, guys, tell me, what is the condition for precipitation? Yes, I'm not able to hear you.
Sir, is the answer HGS?
HGS. Okay, fine. So hope you remember. Oh, there are some conditions. There are some answers. Okay, fine. HGS again. HGS. Harish says HGS. Okay, fine. We'll check. Right. So the condition for precipitation, hope you remember, right, is basically going to be KIP should be greater than KSP. If you find that for any salt, and that's done, that's the condition for precipitation. So let me list out. I have MNS, I have ZNS, I have FES, and I have HGS. So let me put KIP and KSP. Let me, I have to actually calculate. So let me put KSP a little far away. Okay, fine. So now this thing values, the straightforward values are given for KSP. So MNS is 10 to the power minus 15. ZNS is 10 to the power minus 20. This is 10 to the power minus 23. And this is 10 to the power minus 54. Okay, the solubility products are okay. Now, KIP I can easily find. So all the cationic concentrations are 10 to the power minus 3. So it is going to be 10 to the power minus 3 into something, 10 to the power minus 3 into something, 10 to the power minus 3 into something, 10 to the power minus 3 into something. And that something is basically the concentration of sulfide ion. Right now, sulfide ion, now you can see MNS or Zn2 as everything or belong to the type of AB, which will give A plus plus B minus, or in this case, it is going to be 2 plus and 2 minus. You don't have to worry about it as long as the stoichiometric coefficient is 1. In this case, all these are 1. Right? Okay, so you don't have to worry about it. So now it's directly going to be 10 to the power minus 16. They are given in the question. The concentration of sulfide is 10 to the power minus 16. Right, now you see here it will be 10 to the power minus 19. Okay, everywhere it's 10 to the power minus 19. Right, okay. Now wherever I'm going to have KIP to be greater than KSP, and that's what is the answer. Okay, now you see 10 to the power minus 15 is greater. This is greater, so KSP is greater. 10 to the power minus 20 is lesser. Okay, this also, that means 10 to the power minus 19 is lesser than this. 10 to the power minus 19 is lesser than 10 to the power minus 23 also. Oh. Am I doing it correctly? 10 to the power minus 23 is lesser. I'm sorry. Right? 10 to the power minus 23 is lesser than 10 to the power minus 19. Same goes with this. This is lesser than this. And obviously 10 to the power minus 54 is lesser than 10 to the power minus 19. Now, wherever I'm going to have very huge difference, and that is what is going to be the answer, and all your answers are correct. Answer is HGS. Yes, absolutely true. Good. Okay, next question. Okay, I'll just check whether I'm still there. Okay, I am there. Okay, next question. Oh, yeah, guys, I forgot to tell you, right? So in the solubility product and ionic products, I can have the toughest question which can be asked. I'll tell you that. Okay. Right. So the toughest question which can be asked is, if I ask you, what is the KSP? For example, just giving you an example. So what is the KSP of AgCl? Right? What is the constant? What is the KSP of AgCl in the presence of say 1m NaCl solution. So that is what you have to, that is what is being asked. Right now, I want to find the solubility product of AgCl in the AgCl is in the presence of 1m NaCl. Okay, so this is the toughest question, and it's nothing, it's not tough at all. You just have to remember that. Say when I go for AgCl dissociation, right? So it is gonna give me Ag plus Cl minus, right? So I know if this is S, this would be S, this would be S. This is under normal condition, right? Now you see Ag plus no problem, right? Now, but see Cl minus is not only given by AgCl, it is also given by NaCl, Na plus plus Cl minus. Correct. So for AgCl it is just S. Sorry, Ag plus it is just S. But for Cl minus it is not just going to be just S. You are going to add the concentrations coming from Cl minus from AgCl, Cl minus from Na plus, and in this case it is going to become S plus 1. You hope you understand. This is a strong electrolyte. It 100% dissociation, which would give me 1 m of Na plus and 1 m of Cl minus. So the total concentration of Cl minus in this case would be S plus 1. And if I ask you to find the KSP, it should be S into S plus 1. That would be whatever the S squared plus 2S, whatever it is. This would have been the solubility product. Please be very careful with this. Okay, and a lot of times I've seen questions coming like this. They'll give you AgNO3 in the presence of NaNO3, MgNO3, something like that, right? So what you have to understand is you see which is the common ion. So in this case, Cl minus is the common ion. So instead of just putting whatever is coming from the salt, I mean, the sparingly soluble salt, you are going to take whatever is coming from this also and add it. And accordingly, you will calculate the solubility product. Okay, right? So I think we'll just do a question in that form, that model. Next question coming on your way. Actually, we'll do just 2 questions and then we'll wind up. I'm sending you 2 questions right away. So 7 and 8 are the questions. First, we'll do 7, which is in this model, whatever I taught you. And then we'll go for 8th question. And then we are winding up. Has anybody watched Master? Did you guys watch?
So I want to, sir.
You want to? Okay. So let me make you a little jealous that I'm going today. Right.
Sir, will come on Prime, sir.
No chance, man. It got released in this thing, no? What is that? Theaters. So
No,
it is
sir,
not
after
OTTs and theaters are rivalries. They are not going to give it like that.
No, sir, like after a few months when the hype is dead.
I think your voice is breaking. What are you saying?
After a few months, sir, when the hype is dead.
Oh, 1 second, guys. Just give me a moment. I think the Wi-Fi is not coming here. The router is a little far away. Just give me a moment. Yeah, full signal. Yes, Steve. I think it's Steve who was speaking. Yes, Steve, tell me.
Sir?
Yes. So now
Sir,
tell me what do I do?
I said it will come when the hype is dead, sir.
It will come in the
Hype is dead.
hype is when the hype is dead. No. Even that time they might put it in TV, Sun TV, Sky TV, they can give, but not in OTT platforms. Yeah, that can happen. Because these OTTs and what is that? The status are actually becoming a form of rivalries, a big rivalry.
Oh, you mean theaters and Netflix Prime and all?
Yeah, theaters and Netflix and Amazon Primes. I mean, obviously, at the other among the OTT itself, I have competition, but at least they are constructive competitions. but the status and this thing are like perfect enemies, like that way. So they are telling that new films, if it's gonna release, it should not be releasing on OTT platforms. There actually it is a silent protest which is happening from the theater side.
Sir, COVID was useful for streaming platforms. Sir.
Yes, absolutely. Right. So now what happened is, if I want to become a theater artist, I mean, if I want to come in films which is going to release in theaters, like they say that you need to have influence, you need to have contacts and all that. But in case of OTT platforms, for actors' perspective, right? So you don't need to have any background, you don't need to have any contacts as such, right? So it is purely talent oriented in these OTT platforms.
Yes,
But yeah,
sir.
it's little unconventional, but still, change is always required. Okay, so going back to the problem. So it is exactly what I told you, the form model which I showed you now, right? The solubility product, oh, first one, right? Sorry. So the solubility product in water of sparingly soluble salt AB2 is this much. They have given you the solubility product. Oh, wait. Oh, the solubility is given. See, they have given you the solubility. What is that solubility? S, right? So the S value is given in the presence of 0.1 m of A2 plus ion. Okay, exactly what I told you. Right? Just give me the answer quickly, quick. I left my stylus in the place. 1 second, I'll be back. Okay. Done. So we know A, B, two is gonna give A2 plus 2B minus. Okay, this I don't think I have to teach you how it dissociates, right? Okay, fine. So they are given the solubility value to be 10 to the power minus 5. Or if I say it as S, this would be S, this would be 2S, right? I mean, I should not sell it as 2S. It's actually going to be, this S is not going to be just S because I have some other place A2 plus is coming. It's actually 0.1 M. So this is going to be S plus 0.1. And this is going to be 2S. Right. So if I ask you what is the solubility product, that would be S plus 0.1 into 2S squared. Don't forget there is a 2, right? So it will be S plus 0.1 into 4S squared. Right. So if I do that, it is going to become 4S cube plus 0.4 into S squared. Right. So it is going to be 4 into 10 to the power minus 5. That is S. That the value of S is given to you, solubility, 10 to the power minus 5 plus 0.4. Oh, cube, right? So it is going to be 10 to the power minus 15. Okay. 10 to the power minus 5 cube will become 10 to the power minus 15. This will be 0.4 into 10 to the power minus 10. Right? And that's it you have to calculate. Okay. So make sure that you have either you convert this to 10 to the power minus 10 or you convert this to 10 to the power minus 15. Only then you can add. Okay. So you have to write it as 10 to the 0.00004 into 10 to the power minus 15. Or you can write this as 440,000. So I can write this particular expression as, oh no, I'm just exactly telling the opposite. So this would be, let me keep it as 10 to the power minus 15 only, right? plus, I can write this in terms of 10 to the power minus 15. So that will become 4000 minus 15. Yes. Okay. Now you take 10 to the power minus 15 common. So you are going to have 4004 into 10 to the power minus 15. This would have been the answer. Anything matches? Yeah. Just 4 into the power minus 15. Am I doing something wrong? Ooh, yes, I did something wrong. What did I do wrong? Anybody can tell me? Oh no, I didn't do anything wrong actually. Something I did.
Sir, extra zero, sir. 4,000.
Oh, okay. Even if that's the case, the
40,000.
answer is okay. Even if that's the case, the answer is not matching. It's 10 to the power minus 15 only.
Sir, 1
10
into
to the
10
power
power.
minus 5.
So
10 to the
1
power
into
5.
10 right, sir.
So for S cube will become 10 to the power minus 15, 3 into 5, and S square will become 10 to the power minus 10. Correctly.
Sir, I have a doubt, sir. They gave 10 power minus 5, right, sir? 1 into 10 power
Yeah.
minus.
Yeah.
I think that's 4s cube value, sir.
No, they are given the solubility of this salt in water. That is the S value. If they're given solubility product of the salt, then KSP directly, whatever this term, whatever you got, that would have been equal to 10 to the power minus 5. But they're given solubility, that is the S value. So what we're doing is correct, but I think some mistake. What are we doing? For S cube plus 0.4 is correct. Or if we can do it little like this. So if I take 4 4s squared, if I take common from this is going to become S plus, but anyways, it's going to be same, right? Anyways, it's going to be S plus 0.1.
Sir, I think they haven't considered the point one அந்த ஆட் அவங்க ஆட் பண்ணாம டைரக்டா அவங்களே 4s cube தான் போட்டுருக்காங்கன்னு நினைக்கிறேன் சார்.
But that is not correct. Or I understood what they did. They are going for approximation, right? What approximation they are doing is, see, this S value is 10 to the power minus 5. Correct, right? This S value is 10 to the power minus 5, and you see this is 10 to the power minus 1, 0.1, right? So I can write this entire term to be equal to 0.1 approximately. Yes, I can do that. Compared to 10 to the power minus 5, I can, this is like 1 plus 0.0000 something, which will be equal to 1. So I'm telling 0.1 plus 0.0001, I can write it as just 0.1. So if I do that, it is going to become 0.1 into 4s square, right? So this is going to become 0.4 into 10 to the power minus 10, right? Or I can write it as 4 into 10 to the power minus 9. But then also answer is not matching. Correct.
Sir, I think they have just directly put 4s cube, sir. They haven't.
No, if that's what they did wrong. Okay, guys, whatever we are doing is correct. Let me check the solution later. But what we are doing here is absolutely correct. You don't have to worry about it. You don't have to worry about the choices. Sometimes books might be wrong, but this is how exactly you do it. Okay, you can trust me with this. So what we are doing here is correct. Okay, so either this should have been the answer, or whatever, this would have been the answer. What we are doing here is absolutely fine. Okay, fine. Now, what is the time? 6:18. One last question. That's it. 8th question, and we are winding up. Okay, so the solubility product of this salt is this much. Now you see, right, the solubility product is given. Right, now they're asking you, what is the concentration of Al3 plus in the saturated solution of the salt? So what they're asking, guys, concentration of Al3 plus in the saturated solution. What are they asking?
Yes, sir.
S, absolutely. Right. So from the KSP, you just have to find the S. That's it. That's what they're asking. Right. So if it's AlOH thrice, I know what is it gonna be. Okay. Al3 plus OH minus. So this is S, 3S. So the solubility product would be S into 3S whole cube, which will become 27S to the power 4. Okay, so the KSP value is given. What is it? 2.7 into 10 to the power minus 11, or you write it as 27 into 10 to the power minus 12, because it's going to be easier, right? So 27 x to the power 4, 27 gets cancelled. S to the power 4 is 10 to the power minus 12. So can I say S 10 to the power minus 3? Yeah, that's the answer. Is there? Yeah, option D is the correct answer. Wonderful. Right? So yes, I think we'll wind up with this, guys. Okay, we have 10 more minutes, but just you go enjoy. This is the first day of you gonna have daily classes almost, right? So we'll see you. I think tomorrow. What is the day? Tomorrow is Friday. Yes, you have a class. Same like 5 to 6:30. We'll meet you there. And I'm gonna start with the gaseous state next. The chapter is over. Okay, so we'll start with gaseous state, and again it's full formulas. Okay, if at all you can study the chapter and come, it will be wonderful, right? But anyways, I'll just give a quick thing of all the things, right? Quick recap of all the formulas and all the concepts, and we'll directly go for problem solving. I'll take just 2-3 classes to complete it, and after that maybe we'll go for atomic structure. Okay, fine. Thank you, guys. We'll meet again tomorrow.
Thank you, sir.
Thank you,
Thank you, sir.
Yeah.
Thank you, sir.